Hello and welcome to Chapter 5, Lesson 6. We're working with the coordinate plane. It's a scan lesson. It lists two real-world scenarios which you will use the coordinate plane. We use this to, let me change the color, to find a location on a grid. The other thing is to describe an object's location. This is the map shows the layout of a small town. The locations of the buildings are described in respect to the town hall. Each unit on the grid represents one block. Number 1, describe the location of the barbershop in relation to the town hall. So if I look at the barbershop, which is here, and the town hall is to the left of it, so I go 1, 2, 3, 4, 5. So I say the town hall is 5 spaces to the left. Number 2, what building is located 7 blocks east and 5 blocks north of the town hall? But I can tell you right now, this is west, east, north, south. Got that information from right here. So we go to the town hall and we go 5 blocks east. Sorry, 7 blocks east. Let me erase this. So I go 1, 2, 3, 4, 5, 6, 7. And then 5 blocks north. 1, 2, 3, 4, 5. And that blue mark is going to be the firehouse. Number 3, Violetta is at the library. Describe how many blocks and in what direction she would travel to get to the supermarket. So if you notice, we can't just go diagonal. We're going by blocks. So she's at the library. Where's the library? All the way on the top left, quadrant 2. And we need to get to the supermarket. So there's 2 ways she can go. She can go south and then east. That's the way I'm going to go. So 1, 2. It's hard to read this. We got 1, 2, 3. And then 1, 2, 3. So 3 blocks south and 3 blocks east. Or you can go 3 blocks east and then 3 blocks south. You're going to get to the same point. Since town hall and the bank are both located on the same vertical line, the number 0 represents the location of town hall on the number line. What number represents the location of the bank? So we go 1, 2, 3, 4. So the number 4 is going to represent the location of the bank. And we'll get into a lot more details with a coordinate plane. By the way, this is what a coordinate plane is. And this is what we will be going over today. It says identify points on and ordered pairs. It says a coordinate plane is formed when the x-axis and the y-axis intersect at the 0 points. The axes separate the coordinate planes are into 4 quadrants. You can use the location of the plane or use x coordinates and y coordinates to identify the quadrant in which each point is located. So this is, a lot of this information is just information you're expected to know. I'm going to kind of highlight things that you want to pay attention to. There's your x and there's your y. Your point of origin, the 0, is dead in the center. The other things we need to look at is, this is quadrant 1, 2, 3, and 4. You're going to have to know where the quadrants are. So 1, 2, 3, and 4. And you're also going to need to know your x and y coordinates. And the last thing you need to know is the positive and negative numbers. So quadrant 1 has all positive numbers. So these are positive, these are positive. Quadrant 2, the x ones are negative and my y's are positive. In quadrant 3, I have negative x's and negative y's. And in quadrant 4, I have negative y's and positive x's. And I'm looking at this is my x coordinate, and this is my y coordinate, up and down. This is a lot of information for just 1 minute, but as you work with this, the easier it will be. Example 1. Identify the ordered pair that names point C. Then identify the quadrant in which it is located. So I have to look at, when I do ordered pairs, how they always are is this open parenthesis, my x coordinate, comma, y coordinate, close parenthesis. This is called an ordered pair, and I want you to write this down. So at my start, I always start with my x. So I have to find where my c is on my x coordinate. So my x is going to be at 1.5. That's how it is going to be for c. And then I have to go up to find my y coordinate. So I know my x is 1.5 because I found it here, and my y coordinate looks like it's going to be at 1. So when I go to 1.5 and then I go up twice to my 1 spot. So 1.5 and 1. That is my ordered pair for C. And C is in quadrant 1. The thing about my quadrants is I have to use Roman numerals. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Just like that. So yeah, so my x coordinate is 1.5, my y is 1, and this is going to be in quadrant 1. Number 2, identify the point located at -1.5 and -1. Then identify the quadrant in which it is located. So my x is in my negatives, so I'll go -1.5 here. Then now that I'm at my x coordinate, now I need to follow my y, which is -1, which is here. That is my -1.5, -1 value. And that's going to be point B. So point B, and it is in quadrant 3. So I always want to do my x value first and then my y second. So go ahead and try A and B. Use the quadrant from example 1 in order to solve these problems. And go ahead and pause the video. So if we look at A, it says refer to example 1. Identify the ordered pair that names point A, then identify which quadrant it is in. So point A, so I have to do my x values first. So my x values is going to be at -1. And then my y value is going to be at 1.5. So I have -1 and then 1.5. And that's going to be in quadrant 2. For B, it says identify the point located at 1, -2, then identify the quadrant in which it is located. So my x value, my x value is at 1 here, and my y is at -2. So I go +1, -2, and that's going to bring me to point E. And that is in quadrant 4. So now we're going to work with reflections. So the reflection can either be over the x-axis or over the y-axis, or sometimes even both. This is, name the ordered pair that is a reflection of -3, +2 across the x-axis. First, I need to find the point -3 and +2. I know -3 is my x, and I know +2 is my y. So I'm on my x-axis, and I find -3 here, and then go to y, +2. So that's how they got -3, +2. Now I need to reflect it off my x-axis. So since my x-axis is here, this line here, see if I can get more specific. That's my x-axis there. Now I just need to do a reflection. So since I go down 2, and then I'm going to go down to one more time. So 1, 2. Let me see if I can get a better visual. Let me do a different color. So 1, 2. Now I'm back on my x-axis. So go 1, 2 more to get a reflection. It has to be an equal bounce. So it's just like reflecting across a mirror. So my new point is going to be -3, -2. The other way of doing this is to reflect across the x-axis, keep the same x-coordinate, -3, and take the opposite of the y-coordinate. So now my x, if you notice from my original problem, my x stayed the same, and my y is just the opposite from before. So 2 and then -2. That's a reflection across the x-axis. Just remember, whichever axis it's reflecting on, that's the point that's going to stay the same. So I'll do C with you guys. It says, name the ordered pair that is a reflection of each point across the x-axis. I know my x's are going to stay the same. So it's 1 and then +4. This is going to be -2, -5. Because my x's are staying the same and my y's are going to be the opposite. So example 4, it's going to be the same thing. This time it's asking for a reflection across the y-axis. So my y is going to remain the same. Here, that's my y. And my x is going to be my opposite, so my final answer should be +4, +4. So on F, this has got it. Go ahead and do it across the y-axis of -4, -4. So my -4 is going to stay the same, but my x-axis is going to be the opposite, so it's going to be +4. But that's the end of the video, so thank you for watching.